4.3, remainder and factor theorem. They're very closely related. First question. Got a polynomial. Now, it's all cubics at the moment. Power of 3. So when we get to eventually graphing these, you're looking for that, or that, and so on. That's the end game of our questions. First of all, we need to know what a remainder theorem is and what a factor theorem is, because these help you, as Zaid keeps saying, are we going to do graphs? It's all leading to graphs. We're going to divide our equation by x minus 4, but I'm going to show you what remainder theorem is. If you have found a factor, this is what happens. This is like saying one of the factors. Do you know how we have our equation and then we use the null factor law? It's like saying we're looking at the first x-intercept. That's all we're doing. And remember, null factor law says each of those factors we're going to make it to 0 every single time. And it's usually going to be 3. Sometimes it's not 3. But remainder theorem says this. If I can get that factor to equal 0, I'm going to do a backtracking so that my variable is 4. And what happens now, if I punch that into our equation, like so, let's do it all together. 4 cubed. Does someone know their cubes? Pretty cool. 64. 4 squared times a 2. It's negative 32. Plus 20 minus 2. What's our answer? Is it? 50. Okay. What's going on here? So this is what's happening. If I got my equation and I divide it by x minus 4, if I do my long division, at the end of it, you're going to get 50, a remainder. So you have a choice of trying to find if there's a remainder or not. You can either take a very long time and waste a lot of minutes in your SAC, or you can go quickly to check if x equals 4 does it have a remainder or not? Question. If it's a factor, logically speaking, if I put a factor in there, what number should I see here? This is a lolly question. If I divide an equation by a known factor, excellent. Okay. So yeah, Marina, what color do you want? Oh, Perry, who was it? Color? Green's the best. Okay. So we're testing, remember, factors down the line are leading to what feature on the graph? X-intercepts. Factors are like gold. in mathematics. We want the factors. We don't want remainders. So remainders keep us a little stuck. We'll revisit this concept throughout this topic. Okay, next one. We're going to do the same thing here. Instead of x minus 4, we're going to look at 2x minus 1. So if I do 2x minus 1, I'm going to make this possible factor equal to 0. We're going to start backtracking. And what am I going to substitute in our equation? X equals half. Thank you, Jesse. So we can do that now. You can work ahead of me. You can punch that in. Half to the power of 3 becomes 1/8. Half squared is 1/2 back because of the 2. 5 halves. 5 halves. Take away 2. Who's got an answer for me? 1/8. It's 1/8. Thank you, Jesse. My 8's a bit weird. What we're saying here, if you did long division with the equation, you can go all day. You'll get 1/8 down here. If you don't believe me, you can try it yourself. This is the remainder theorem that when you substitute it into the equation, it's going to spit out the remainder. So what that means is if I do long division, I'll get some sort of answer up here, but the remainder will be 1/8. Okay. Over 2x minus 1. Okay. Who's heard, is this the first time you've heard of remainder theorem? Yes or no? No. No. So you did it last year? You've heard of it. Okay, great. Okay. Let's go next question. Okay, we've got an equation there. You can see that there is a d. We're trying to find that d. Here are the clues. When that equation is divided by, I'll just redivide. Save us some time. Okay. When an equation is divided by x plus 2, the remainder is 9. Find the value of d. I've got to find an unknown. What are you going to do with the information provided? What steps did we do before? What are we going to do with the x plus 2? Yes. Thank you, Jesse. Jesse, in his head, he's making it equal to 0, but he's backtracking from there, equals to -2. We are now going to put that into here. For every x that you see, It needs a -2. 9. How are you going to make use of 9? 9 equals that equation. So this equation that we've got here is going to be 9. Got to connect all the dots together. And then from there, it's 9 equals 4 plus d equals 5. Okay. Any questions with that? Okay, we're going to move on to factor theorem. Show that x minus 1 is a factor of x4 plus 2x cubed minus 7x squared minus 8x plus 12. So we know it's a factor. So technically, if I do long division with the x minus 1, if it's a factor, as Perry said before, I'll do all my working out. What should I get? 0. Thank you, Zach. What do we mean? 8 divided by 2 is 4. There's no remainder. So we know that 2 times 4 is 8, no remainder. These are factors. We've proven because no remainders. But if we did it again with the 3, it will be 2 times 3, 6, remainder 2. A remainder pops up, not a factor. Factors, remainder 0, which is what we want. Okay? What's the difference here? If I have a factor and over here, and then I have a remainder over something, I'm just going to say x minus 1. Hopefully you get this bit here. This is factors. That means when I break it into factors, I can use null factor law because this could be the 0 or this can be the 0. That's nice. It fits nicely. However, if I've got a remainder, can I use null factor law on here? On this one here? Why can't I use null factor law when it's a plus? Thank you, Tim. Who else thought that was the answer where I was leading to? Okay. Tim, forgive us, suggest it because you've been paying attention and Zach forgetting that. Oh, sorry, Zach. Okay. That's really important if you can make that connection. Okay, back to this one here. Therefore, if I don't want to do any working out, if I want to prove x minus 1 is a factor, and I don't want to do any working out, what am I going to punch in to our equation, say, if it's x minus 1? It's going to make it equal to 0. What's my x going to be, Zay? Just 1. Just 1. We're going to punch a 1 in here into our equation, 1, 4, plus 2 times 1 cubed, minus 7 times 1 squared, minus 8 times 1 plus 12. It's getting messy. 1 plus 2 minus 7 minus 8 plus 12. And that should be 0. That's a 0 if I haven't made any mistakes. Okay. Any questions with that? Says here, there's two parts to the question. We've done the first part. We've shown you there's a factor because 0 has appeared in our remainder theorem. Now we're going to find the other linear factors. We're not done yet. Okay, step 1. We need to prove that x minus 1 fits into the equation as a factor. It means we're going to get a 0 remainder. But in order to find the other linear factors, this is where the linear factors start to appear. So to prove that it's a factor, you can take a shortcut. But to get the actual other factors in the equation, you need to do long division to get it. Because we're after this line here. You got to do long division. Okay, are you righteous? Yeah, so let's do that right now. Okay. I want an x4. Let's go nice and quick. What needs to be up here, Maya? To get an x4? x3. -1 x cubed is negative x cubed. We minus 2 take x cubed, Perry. 2 take x cubed. It's a 3x cubed. Okay, and Rita, what needs to happen now? Bring it. Excellent. Okay. Thank you. We want a 3x cubed here. Amy, what needs to be up here to get a 3x cubed for this? 3x squared. -1 times the 3x squared. So negative 3x squared. What's the answer going to be here, Nathan? -7, take 3. -4. Tim, what do we do next? Thank you. I want a -4x squared down here. Jesse, what do I need up here? -4. Good. And -1 times -4x, so positive 4x. Zach, what's down here?
Plus 4x.
Not
Oh,
quite.
wait, no. Minus
What?
minus 12.
Minus 12x. What needs to happen now, Zaid? With that negative 12x?
It's got to go up the top.
Not quite.
Up the. Drop the 12.
Drop the 12. What needs to be up here is the -12. We get a -12x. And guess what? Look at that. -1, -12. They're both the same, so when we minus, it's a 0. It's proving that it's a factor, which we did it in shorthand right here, but we've got a revelation of what happened, a greater part of the graph. So let's just create some space to see what's happening. What are we trying to say? We're saying that the original equation we are saying that we can rewrite this now. How can I rewrite this here? Who wants to have a go? Instead of writing this original equation, what can I now, how can I write it in a different way using the information that you're seeing on the left?
X minus 1 times the lead.
Excellent. Okay. We can. We've broken up here. But what's the point of breaking a big equation like this into brackets? What's the point? X-intercepts. Thank you very much. Okay. So, we are now going to tackle this person here. Oh, I'm giving them personalities again. We've established one factor. Now we're going to try and break this guy down. We're going to focus on him. So we're going to say that's a new equation there. There's an equation within an equation. And you will need, I'm sorry, at year 11, I know you got your CAS there, but you need to know how to do it on paper. Year 12, not so much. You have to be really equipped on your CAS next year. And so this is a bit of an introduction. We're going to try and break this down, but once again, we're going to put it through the grinding factor remainder machine once again. We're going to treat it as it's a new equation. So therefore, does anyone know, remember we're trying to get factors. We've got our first factor. Can anyone guess me the number that goes into here so that I can get a factor? And what should I get at the end if it's a factor? 0. What's that number?
1.
It's not 1. It's not 1. It could be 1. Actually, no. It's not 1. Okay. It's 2. It is 2. Now this you do by trial and error. I know Zach was saying you did trial and error for something. For how long? A while. Look at that. Nice and mirror. 8's are going to cancel out. The 12's are going to cancel out. Bang. 0. Therefore, what do I do with the 2? Okay. What am I going to do with the 2, Maya? Excellent. I'm feeling generous because it's Friday. Purple's the good flavor too. In a 2, we're now going to make it x minus 2. We're going to use that now. Good pick up, Maya. So what does that mean? I'm now going to divide x minus 2. This is where it's important not to lose track. But where am I going to divide the x minus 2 into which equation? Which one?
That one over there.
That one over here?
Yeah.
Thank you, Tim. We're going to go again. Another round of long division. Okay, you guys are going to be experts at long division. Okay, what needs to go up here, Maya? X squared. What goes down here, Emily?
Minus 2x.
Thank you. Harry, what goes down here? Excellent. What do I need to do here, and Rita? Thank you. Amy, what do I do now? I want a 5x squared here.
And you put 5x.
Thank you. Nathan, what goes here? Negative 2 times a 5x. negative 10x. Tim? Excellent. What do I need to do now, Jesse? Thank you. What do I need up here, Zach? To get a 6x? 6. Thank you. And what goes here's 8?
12 again.
Okay. What's number 12?
Negative.
Thank you. Look at that. We get a 0. And we're happy. Why are we doing the long way? No. We've already shown it. We've already shown that it's a 0. This 0 here is this 0 down here. To find the other factors. Okay. Now, look at the x squared plus 5x plus 6. You've probably seen that in your textbook somewhere. I'm hearing you, Tim. Okay. X squared plus 5x plus. Thank you. Okay, look carefully. I just hope I haven't missed anything. Okay. Look carefully. This in red is those two blue. We have our x minus 2 that we were using, so that's there. And what did we have at the start? X minus 1. What did we just do? We have, well, obviously it's not cubics. What graph are we doing right now? I'm just showing you. X4 is a? Quartic. Thanks, Erin. We actually did a quartic. And slowly by slowly, we started revealing through long division, factor theorem, remainder theorem, we broke it up into factors. That's what we just did. And what's the point of breaking an equation like this down? X-intercepts. That means, look, if I use my null factor theorem, I use my big fat 0, and I can start picking these off. X minus 1 might be the 0. X minus 2 might be the 0. And so on and so on. X plus 2 might be the 0. X plus 3 might be the 0. At 1, 2, negative 2, or negative 3. Okay. If we were to sketch this, it would do something like this. 1, 2, negative 2, and negative 3. Oops. I wish I was a bit neater. It's going to hit here. 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 We want a quartic. Exactly that. It's like that. Oops, I missed it. You get the picture. Okay. Down the track though, for this sack here, not quite a sine wave because it keeps going up.
Oh yeah.
You guys are gonna have a lot of fun with trigonometry this year.
Oh no.
Circular functions. How's that for you? It's coming. Just be ready. We've got our x-intercepts. If we were graphing this quartic, what would you also need to find at this stage anyway? The y-intercept. And a bit further down, turning points. Turning point, and there are three. And that's another topic. But we keep it simple at the start. If you call this simple. All right. I've got to finish this off. There's one more thing.
Second step.
Yeah. Yeah. Yeah.
But we can't even try.
If it says show full working out, you got to do it this way. Okay. All right. Last thing today.
I'm in the 12. Oh, that's fine. I forget.
Okay. I'm not going to do this whole example. You're going to get a copy of this though. Tim, Zach, you can do it at lunchtime. Okay. We have something called the rational root theorem, and you use this when you are struggling. Okay. What do I mean by this? We're trying to find out when you are struggling to find out a number that goes nicely in here, guess what? It's probably not a whole number. It's going to be a fraction. If you're a genius, you could probably figure out the fraction in here. But this is the clue. This is what we do when we're stuck. We're trying to find out what goes in here to get a 0. That's what we're after. You will get the factors of the last number, and we're going to divide it by the factors of the front number. Okay? Just quickly, the last is our -3, and the front is our 2. And we also want to make allowances for any positive and negative versions of it. What does that mean? We're going to have positives and negatives. What are the factors of 3? 1 and 3. Of 2. 1 and 2. What we're trying to say here is our root, the thing that we put in here could be 1 on 1, 1 on 2, 3 on 1, or 3 on 2. It's going to be one of those. This is called rational root theorem, and it does work. Because I've cooked this up before, I know which one's going to work. The one that works is 3 on 2. Okay? Oh, good. I should have asked you.
So
It's not.
Well, you trial and error again. Okay? It's really hot in here. Okay? So, if you actually calculate all of this by hand and you do it correctly, it's going to actually equal a 0. But what does that mean? If it's 3 on 2 here, then what's my factor going to look like?
X minus 3 on 2.
Excellent. But when we divide, hopefully I can get this done in time. I'm not going to do all the working out. When we do a division, I don't want to do that. Why? What's really ugly looking in here? A fraction. So let's muck around with this. Let's change it. X equals 3 on 2. Okay. Then we can bring the 2 back. And then 2x minus 3 is equal to 0. So we work on numbers that aren't fractions. Instead of x minus 3 on 2, it's easier to use that. And then you do all your journeying. Okay? Yeah. Decimal. Because why? It's first of all, it's a recurring decimal, 2/3. It goes on forever. You'll miss. What should we get in here if it's a 0? And what do we get in here? Other factors. Well done, guys. You were listening. Okay, that's the gist.
Announcement for lunchtime. Would the following students please come to the general office? Alexandra Jankel,
So I want
Isaac Javanovsky, Daniela Jacobi.